So this is the fourth video on semester 2 review for video on semester 2 review for final exam, geolechy. Some more circle practice on this. So on this first one, we know that this is the center O. BAC arc measure BAC is 316. So let me get that in here. So going all the way around, let me just follow it. This is going BAC. Wow, that's a bad circle. Okay, BAC all the way around to here is 316 degrees. And we want to find angle B. So we want to find this angle right here. That's the angle I want. So what I do know is that this right here, I'll do it in orange, this arc measure here is going to be 360 minus 316. So I end up getting 44 degrees. So this is 44 degrees, which means that this right here is 44 degrees. And that means that if that's 44 degrees, then let me just write it in here. Hold on, write it in. I'm going to zoom in for a second. I'm going to write my 44. Okay, so then this is 44 degrees, which means that this is going to be 180 minus 44. This is going to be 136. And because together they have to form the straight line, okay, which is 180 degrees. And then this angle right here, I'll just do it in black, is going to be half of the 44 because it is an inscribed angle that forms that intercepted arc. So this is going to be 22 degrees. So I know that I got 180 minus 136 minus 22, and that is going to give me my angle B. So 180 minus 136 minus 22 gives me 22 degrees. So my answer to this is C, 22 degrees. On B, okay, so on this one, I know PSQ, angle PSQ is 2y minus 5, so 2y minus 5. And I know that PRQ, which forms the same intercepted arc, is y plus 30. So this is y plus 30. So since they both form that same intercepted arc, this one right here, I know that they have to equal each other. So I can take 2y minus 5 is equal to y plus 30 and solve, and I get y is equal to 35 degrees. So B. Okay, on number 3, putting this in vertex form. So I'm going to subtract 11 from both sides. And then what I want to do is I want to take half of my B, which is -4. And then I need to square that, which is 16. That's what I'm going to add to both sides. So I'm going to add 16 to this side and 16 to this side to make it a perfect square. So this is going to be y plus 5 is equal to the quantity x minus 4 squared. I am going to minus my 5. So I get x minus 4 squared minus 5, and that is vertex form. On number 4, again, remember that since that is a radius that is meeting that chord in a perpendicular manner, that means this side and this side, it's a perpendicular bisector. So this is going to be 6 and this is going to be 6. And then my x is my radius, so that means that this is also x. So I'm going to do Pythagorean, and I'm going to get 16 plus 36 is equal to x squared. So I get 52 is equal to x squared. And looking at the answers, they have them. So this is going to be the square root of 52 is x. And really, I could break this down to a 4 times 13. So that would be a 2 root 13. But they didn't have it in that form. They could have. They have it in decimal form. So I'm just going to put the square root of 52 in my calculator. And we can approximate it. 7 times 7 is 49, 8 times 8 is 64. So it has to be the 7 point something. And when I do put it in my calculator, was it 52? I get a 7.21. So 7.2. Okay, this is just laws of exponents. So 4 is going to be raised to the third. My y squared is going to be raised to the third. My m to the third is raised to the third. So 4 cubed is 64. Y squared raised to the third, power to power, you multiply. So y to the 6th. M, again, power to power, we multiply. So m to the 9th. And that's my answer. What is the measure of each interior angle of a regular 24gon? Okay, so this is how I would probably do it. I know that the sum of my exterior angles is always 360. So if I take 360 divided by 24, so 360 divided by 24 is 15 degrees. Okay, that's not my answer. So let me pretend that I'm drawing this right here is, let's say, the answer I'm looking for. That's one of the interior angles. What I just found was an exterior angle. And so this would be 15 degrees. So together they have to add to 180. So I'm going to take 180 minus 15, and I'm going to get 165 degrees. That's how I personally would do it. There is another way to do this problem. You can use the formula where we saw, and if you don't remember, you can always draw it out. Just as an example, let's say I have a pentagon and we had split this. Remember, we started at one vertex and we split this into different triangles. And we saw for this pentagon, we had 3 triangles. So each of these triangles adds up to 180 degrees in terms of the angles. So we know we take 180 times however many sides you have minus 2. And then I'm going to divide it by 24 because I have 24 angles here. So 180 basically times 22 divided by 24. When I put that into my calculator, I get that same 165. So the way I'm thinking about it over here is I'm trying to find the exterior angle because I know they add to 360. So again, this is my exterior and this would be my interior, and together they add to 180. Either way. Okay, number 7, another cylinder. So I want surface area. So the area of the top is 4 pi times 2, because I also have the area of the circle on bottom. So that's 8 pi. Then my rectangle, which is the around, like if it was like a soup can, it would be like your label. If I cut it off, this is 3. This going, let me just make it a little fatter. This going all the way around here is circumference, and circumference is 2 pi r. So since my radius is 2, that is going to give me 4 pi, and that is the same thing. So this answer is going to be 12 pi. So I'm going to have 8 pi plus 12 pi, which is going to give me 20 pi meters, where we're looking for surface area squared. On number 8, we want to find the volume of the cylinder. So the volume, I'm going to take my area of my top base, which is 4 pi, times it by the height, which is 3, and we get 12 pi meters cubed. And that's your volume. Number 9. Okay, we've seen a couple of these. Because that meets perpendicular and it goes through the center, because it is a radius, I'm going to have this be a perpendicular bisector. So this splits to a 5 and a 5. Then this is a radius, which means that this is also the same as x. So by Pythagorean, 4 plus 25 equals x squared. So 29 equals x squared. So x is going to be the square root of 29. On number 10, this is a 45, 90. And so this is isosceles. So I have a 5 and a 5, and then this one is a 5 root 2. So our answer is 5 root 2. You take your 2 legs and you times it by root 2. Perimeter. Okay, so this is a 30, 60, 90. Across from my 30, that's kind of my base. I double that to get my hypotenuse, so that's 8. I times that by root 3 to get the one across from your 60. And so my perimeter is going to be 12 plus 4 root 3. And if I put it in my calculator, I end up getting about an 8.9. On number 12, an equilateral triangle has side lengths of 8, and we want to find the height. Okay, so let me get a triangle here. See if I can get it to be. Okay, that's about it. So this is basically, oops, still in triangle, 60, 60, 60, because it's equilateral. This is 8, this is 8. So what that, and all sides are 8. So when I split this in half, this is now going to be a 4 and a 4. And this is going to be a 4 root 3, because this is now a 30 degree. And so the height is going to be 4 root 3. Surface area of this rectangular prism. So basically, this piece right here is going to be 5 times 2, which is 10. I can times it by this length here, or width or height, whatever you want to think about it. And so I'm going to get 40. Because I'm taking that area of that base, timesing it by what would be like the height if I'm standing it up. And that is meters cubed. Oh, sorry, surface areas, meters squared. Find the length of a 30 degree arc in a circle with a radius of 3. So if I get a circle, and my radius is 3. Oops. And I have a 30 degree angle. And because the arc measures also 30, and they want us to find the length of a 30 degree arc in this. So we want the arc length. I know the arc measures 30. I want the arc length. So I'm going to find circumference, which is going to be 2 pi r. So I'm going to get 2 pi times 3, or 6 pi. I don't have the whole circumference. I have 30 out of 360. So that is going to be 180 pi over 360, which is pi halves. Centimeters. Okay, on 15, we have a hexagon. And a regular hexagon, which means all of these, if I could draw nicely, are equilateral triangles. So that means that all of these angles here are 60, 60, 60. So if I take one of these triangles and I split it in half, again, this was 60, this is 90, this is now going to be 30. I know the sides are 8. So what that means is this is 8, this is 8. It's 8 going across this bottom, but it's going to be a 4 now and a 4. And then across from my 30 is my 4. I double it, I get my hypotenuse, which is 8. And my height here is going to be 4 times root 3. So if I was to find the area of one triangle, I would take 1/2 my base, which is 8, times my height, which is 4 root 3. So half of 8 is 4. 4 times 4 is 16 root 3. That's one triangle. I have 6 of these things. So when I take 16 times 6, I get 96 root 3 centimeters squared. And that will be our answer. Pretend this is a circle. It got kind of stretched, it looks like. Pretend it's a circle. Okay. And that this is a square. Okay. So I'm going to have 144 for the area of my square. And since it's 12 going across, that means this is 6. So the area of my circle would be 36 pi. I subtract them, and that would be my answer. Okay, so this inequality, I'm going to have 5x squared plus 2x minus 3 greater than or equal to 0. I'm going to factor this. So I have a 5x squared, a negative 3, which means I have a negative 15x squared, and I has to add to a 2x. And that is going to be a 5x and a negative 3x. So 5x and negative 3x. So my outside, I've got a 5x and an x times negative 3, 5x times 1. So I'm going to have 5x minus 3 times x plus 1 is greater than or equal to 0. Let me find my boundary values here. So I solve this and I get 3/5. I solve this one and I get negative 1. So on a number line, I'd have negative 1 and I'd have 3/5. And these would be solid dots because these are your actual values that make it equal to 0. But what I want is where it's greater than 0. So I think about the number line as my x-axis, and negative 1 and 3/5 are both x-intercepts, and my parabola is a positive parabola, so that means it opens up. So I'm above, at 0, below, at 0, above. And I want it greater than. So since I want it greater than, I am going to be starting here at negative 1 going this direction, starting here at 3/5 going this direction. My answer is going to be x is less than or equal to negative 1, or you need the word or when you have more than one piece of branch. X is greater than or equal to 3/5. Okay, on 18, what is the sum of the measures of the interior angles of an 11gon? Again, I'm going to work it out 2 ways. I can go 11 minus 2 times 180 divided by 11. So if I put that in my calculator, 11 minus 2 times 180 divided by 11, I ended up with 147.27. Oh, I want the sum. I misread that. I was going to find all of them. I want the sum. So I don't need to divide by 11 because I want the sum. So 11 minus 2 times 180, I end up with 1,620. That is my answer. Again, I need to be careful when I read sum. Okay, I'm going to factor this. So I'm going to do a box to diamond. So I have a 2x squared. I have a negative 15. That gets us a negative 30x squared. Needs to add to a negative 7x. So negative multiplies to negative 30, adds to negative 7. I'm going to think, get rid of my circle, sorry. I'm going to think negative 10x and positive 3x. So negative 10x and positive 3x. So I'll put my 2x here and x here, x times 3, 2x times a negative 5. So my factors are 2x plus 3 times x minus 5. Okay, on 20, I know that this has a central angle of 60 degrees. The area of the whole thing would be 36 pi. I don't have the whole thing. I have 60 out of 360. And so my 36 goes into this 10 times. 10 goes into this 6 times. I end up with 6 pi as my answer. And if I put it in my calculator, 6 pi, I end up with about, and this is centimeters squared. I end up with about 18.85. And that's the end of this 4th video.